Alright, so this video will focus on 10.3, and we're going to continue on with probability, and we're going to talk today about experimental versus theoretical probability. So it says that a number cube is ruled, determine the probability of each event. So if I have 5, that would be 5 out of 6, or I'm sorry, it'd be like one number 5 out of 6 outcomes. So that'd be 1 out of 6. The even number would be 3 out of 6. This would be 2 out of 6, 1 out of 6, 3 out of 6, or 3 out of 6. And of course, you'll notice, like if I said 1 out of 6 or 3 out of 6, the 3 out of 6 got reduced down to 1/2. And this is what we did the last couple days with the warm-up, just trying to put it in lowest terms. And we'll see why today. So how can you use relative frequencies to find probabilities? And the first thing we're going to do is take a quarter, flip it 20 times, and then are the relative frequencies the same as flipping heads or tails? Well, here's the thing. Again, this is experimental probability. So you should have 10 and 10, but it might be different. The frequencies might be close. It might be 3 and 17. I don't know, but the more you play, the closer I'll get to 50-50 because there's only 2 outcomes. So doing it 20 times, probably not a very good indication. But if each group did it 20 times, and then we calculated everybody in the class, and we added up all the different groups, which we'll probably do in class, chances are I'll be closer to 50-50 if we do it that way, because there's going to be a couple outliers. If we look here, it says work with a partner. You have colored chips. You select chips from the bag and then replace it. So if I take a green out, I'll then put the green back in. All right. And the reason why we do that is because you have the total amount of outcomes stays the same because you don't remove a chip from the bag. So every time you do it, you still have like 20 chips in the bag, right? So I have 20 chips in the bag. Could you use this table to find the exact number in the bag? And I want you to think about this for a second. What can you do? If we go through here and we have, I would guess that there's probably definitely more reds than there are yellows, right? So what we could do is kind of add these up. So I could do 24, 12. So of course I have 36 plus 15 equals 51 plus 9 equals 60, right? So I have 60 different things that I've done. So I have like 24 out of 60 times 20 because there's 20 chips in the bag. And I can cross cancel. So I'll have 1 over 3. And 24 divided by 3 means that there's probably like 8 red ones. And I could take 20 or 12 over 60 times 20. And again, if you look at it, all that I'm doing is dividing by 3, really, right? I'm taking these numbers divided by 3. So this becomes 4. This becomes 5, and this becomes 3. If I add this up, I have 12, 17, 20. This is a guesstimate. It might not be exact, but I could at least get kind of an idea of where I'm going to be based on doing this. So it says you do this 50 times now, 100 times. So which experiment do you think would give a better approximation? The more you do, the more times you carry out an experiment, the more likely it is to be closer to that theoretical. There could be outliers here. So if you did it like a billion times, it'll be a much higher percentage that you have the right numbers here than if you just did it 20 times. So then I have this right here. I have a thumbtack. I toss the thumbtack onto a table, and there's 2 ways it can land, this way here or this way here. And a buddy says, it's a half chance of doing this and a half chance of doing this. Do you think that's true? My guess is no. I mean, here's the thing. There's a few things. First of all, just the balance. So like center of gravity. When it lands, it might bounce here and then go on its side. Surface area, another thing. Does this have more surface area or does this? This is not truly 1/2 chance. And then it says here, toss a thumbtack 50 times on a table and record your results. So is it equally likely to occur? We have to do this in class and check it out. So we'll do that. You flip a coin 100 times. How many times do you expect it to be heads? Well, 50 you would expect, right? But it might not be. And then the other one says that I have a bag containing 3 red chips, 9 blue chips. You draw a chip and replace it 100 times. So again, I'm doing here. Let's just say, 9 over a total of 12, right? Times 100. I reduce these things here, so I'll have 6 and 50. Could probably pull out a 2, so I have 3 and 25. here. I can then reduce these right here, right? 9 and 3, and this becomes 3 and 1. And 3 times 25 equals 75. Again, all that I did is I took 9/12 times 100, and you get 75. It's also because this is 3/4, right? And 3/4 of 100 is 75, if you think of money. So what we're going to be doing today is there's really two key ideas. One is experimental. So this is the number of times that you actually tried the event. Or I'm sorry, the number of times that the event occurs. And it's over the total, right? So that's the experimental. So this is actually like playing the game. I'm going to write that down. Play the game. And, you know, sometimes there's outliers here, but this will give you a good indication of what the probability should be. So for instance, here is rolling a number cube. And when you look here, I rolled it 50 times. So that's a good amount of times. And it says, what is the experimental probability of rolling an odd number? Well, I have 10. I have 8. I have, this looks like 11. So if I look here, I have 18. So that's what, 29? So 29 out of 50. So that would be 58%. The way that I did that is I just divided the two. And I actually just thought about if I multiply this by 2, I get 100, and this by 2, I get 58. So I knew it would be 58%. It rained 2 out of the last 12 days in March, so I take 2 divided by 12. And I could do this real quickly. You could I could go through and multiply this now by 30 because there's 30 days in April. Just want to show you something. And if I would do this, I would have 60 over 12, which equals 5, right? So I'm expecting that it's gonna rain like 5 days of the month out of 30. But the other way you could do this is I could reduce this, make it smaller. So 2/12 is also 1/6, right? This is why we were simplifying fractions before. Times 30. And now I can cross cancel, and this becomes 1, and this becomes a 5. And that's how I get my 5 as well. So there's two ways to get to the 5, but this is what we're doing. And I multiply by 30 because there's 30 days, right? So let's see what they have here. So 1/6 times 30. Again, you could also do 2/12. I showed you that. Example 1, what's the chance, the experimental of rolling an even number? So example 1 again. So an even number would be 4, 11, and 6. So 4 and 6 is 10, plus 11 is 21. So 21 out of 50. Clothing store, there's 5 defective pairs of jeans out of 200. So all that I'm doing, just to set this up so you know, is I'm just going to go 5 over 200. I could, of course, reduce this down if I'd like, and I'll do that underneath here. I'll say 1 out of 40, and I'll say times 5,000. So in this case, I'll have 25,000 over 200. These go away. And I have 250 divided by 2, which equals 125, which is the answer I have. If I had this one here, so this is kind of the same thing where I have my 5,000 over 40. This goes away. 500 divided by 4 is also 125. So it really doesn't matter how you set it up. They both will work. But that's just how you do it. The other one is theoretical probability, and this is what should actually happen. So this is the number of favorable outcomes out of the possible outcomes. So experimental probability, the more you do, should get close to this theoretical. This is the likelihood mathematically of what should happen. So you randomly choose one of the letters shown. What is the theoretical probability of a vowel? So I'm not sure where the letters shown are. Sorry. I guess I forgot that slide. But if I look here, it says here the theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel? Well, if you think about this, I have a 1/6 chance of winning, right? And my chance of winning is 3. So I'm really taking like 3 divided by 1/6, and I should have 18. So I have 1/6 because I have a 1 out of 6 chances of winning. and 3 out of the total, whatever the total is. So if I look here, I cross multiply and I get 18. A couple more examples here. Let's just try this one here. So the bar graph shows the rolling a number cube 300 times. So here's my 300 times. What's the chance of getting an odd? So I do 48 plus 50, so I have 98. And then 98 plus 49 is 147, right? 147 out of 300. And that is really a lesson